So we start the second lecture, continuation of the previous lecture. Here we understand the domain of the relation. What is the meaning of the domain of the relation? You can see in your screen is definition is given in the in your screen. The definition says let R be a relation from a set A into a set B, then the domain of R denoted by capital DR is the set DR equals to, which should be the member, all such A such that A belongs to capital A and there exists, this symbol is known as the there exists symbol, there exists a element B belongs to capital B such that A comma B belongs to R. So clear the concept of this definition using the previous example. Here is the previous example. So if we consider this example, what should be the domain of this relation R? Because 1 comma q, 2 comma q, 3 comma q and 4 comma p are the member of the relation R, according to the definition it says that the domain of R, it's represented by dr, is the collection of all the member of the set A, okay, of the set A such that A comma B belongs to R. That means the domain set should be a subset of the set A according to the definition. So the domain set of the relation R from according to this example should be 1, 2, 3, 4. That means the domain set of the relation R is itself a set A, because every element of the set A is somewhere related to some element of the set B. So A, the total set A should be the domain set of the relation R. Now we clear according to the diagrammatical representation. If we consider this one, if we consider this diagram, this one, you can easily observe that 2, there is an arrow from 2, whatever may be the number of arrow, that doesn't matter, but if it has an arrow from this particular element, from the left hand side element, this element should be belongs to the domain set of the relation R. So 2 3 5 should be the domain of the relation R according to this example. So here we use 2 3 5. In the figure 1.1 we have mentioned the figure number 1.1, the domain set is 2 3 5. Next we understand what is the meaning of the range or image of the relation. You can easily observe the definition is written in your screen. Definition says the range or the image of R, the range or the image of R denoted by IR, because the spelling of the image is starting from I, so here we mention the image is IR. Some books use the notation IM, the first 2 letter of image IM of the relation R is the set. IMR is represented by all such element B, okay, all such element B such that B belongs to the capital B and there exists A belongs to capital A such that A comma B belongs to R. That means every element A comma B. That means we just take all such B where A comma B belongs to R. According to this example, if we consider this example, we start from the first example where we can start our lesson. This one is the example. Here it's the here is the domain set A. Where is the set A and B? We just make a relation R which represent A is divisible by B. Sorry, A is the divisor of B, or B is divisible by A. In that case, we find the subset of A cross B using the subset. The notation of the subset is using here R is the relation. So 2 comma 10, 2 comma 12, 2 comma 13, 3 comma 12, 3 comma 13, 5 comma 10 and 5 comma 30. Sorry, 30. So if we consider the what should be the domain of what should be the range of the relation R, that should be 10, 12, 30, no more element. That means here the number of element is 7, 10, 12, 30, but just we consider for the image case 10, 12 and 30. So here we explain the same example using arrow diagram. Here you can easily observe where the arrow end, in which number, that should be the element of the domain set. So that should be the element, sorry, that should be the element of the range set, that is 10, 12 and 30 should be the range set of the relation R, or the range of the relation R. This one. So here we use this one, 10, 12 and 30. Next we observe what is the meaning of inverse relation. What is the meaning of inverse relation? Here we again give the definition and make a clear idea through a proper example. So let R be a relation from a set A into a set B. Then the inverse of R denoted by R inverse. It's the way of representation. R inverse is the relation from B into A. When we make a relation R from A into B, then the inverse relation R inverse should be a relation from B to A. Okay, which consists of those order pair when the reverse belongs to R. That means the inverse set consists those B comma A such that A comma B belongs to R. We consider only this B comma A where A comma B belongs to R. Okay, if we consider according to the first example, that is your first example. So if it's your R, then the R inverse you can easily write here R inverse, that should be Q comma 1, Q comma 2, Q comma 3 and 4 comma P, nothing more. So here it's another example. You can easily observe the inverse relation R inverse according to the previous diagram. According to this diagram, A is the set 1, 2, 3, 4. B is a set P, Q, R. If we consider the Cartesian product of A cross B and take a relation R according to this diagram with this previous example, 1Q, 1Q, 2R, 3Q and 4P. 1Q, 2R, 3Q, 4P. So the inverse of the relation R should be Q1. So here we give an arrow from Q to 1. Next one is here is 2R. Therefore the inverse relation consists the element R2, R comma 2. This one is 3 comma Q. So the inverse set consists Q comma 3. So Q 2, 3. And the last one is 4 comma P. So here we use P comma 4. P comma 4. Just to make an arrow from P to 4. Okay. So you can also note it if it's your note. You can easily observe that the domain of R, if we consider the domain of R set should be the range of the inverse set. Am I clear? Domain of R set, domain of R should be the range of, should be the domain of R should be the range of R inverse. So the range or image of R inverse, and image of R, image of R should be the range of should be the domain of R inverse. Okay, so you should observe this one. It may be a multiple choice question. Next one is the composite relation. Next one is the composite relation. What is the meaning of composite relation? RB a relation from A into a set B, and SB a relation from the set B into a set C, then the composition of R and S denoted by S composed R. You should remember this one. Composition of R and S denoted by S composed R is the relation from A into C, defined by, for all A belongs to capital A, C belongs to capital C, A is a composite relation of S composed R to C if there exists some B belongs to capital B such that A comma B and B comma A is are related to B and B is are related to C. You can easily understand this concept according to this diagram. You can easily observe this one is R related to P and P is S related to I. Therefore, if we make a composite relation R composed S, here we write the S composed R, then one is R related to P, P is R related to I. So one is S composed R related to I. So here we make the diagram. One is is related to this diagram. Okay, next one is 2. One is another are related to S is are related to A, therefore one should be S composed are related to S. So here we mark a arrow from 1 to A. Similarly, 2 is are related to S and S is are related to A, so 2 should be S composed are related to A. And according to this diagram, I think 3 is are related to Q, Q is are related to no one, so 3 should not be the element, there hasn't any element which is S composed are related to 3. 4 is are related to T, T is are related to E, therefore 4 is related to E with the composition is composed R. Similarly, 4 is are related to W, W is are related to O, so 4 is S composed are related to O. That is the composition or the composite relation. It's also applicable for when we study this composite relation. In that case, when we study the transitive relation, you should understand what is the composite relation. So that is your second lecture. Wait for the third lecture. We just move in the third lecture with a different type of relation. Thank you for listening and happy learning.